Hey, what's up, guys? John here again. And this time I want to talk about this week's one of the contest problems in this week's weekly contest, uh, number 1536, minimum swaps to arrange a binary grid. And so you're given like a n times n by n binary 2D grid. Binary grid means there could be only 0 or 1 in each cell. And in one step, you can only choose to switch two adjacent rows. Notice here, only switch two adjacent rows. And the grid is said to be valid if all the cells above the main diagonal are zeros, which means if we have a n by n grid here, okay, and there's a diagonal, that's the main diagonal. Basically, all the elements above the diagonals should be all zero, okay? And it asks you to return the minimum number of steps, basically the minimum swaps it's needed to take to make the above all the all the all the cells above the main diagonal to be zero. If there's no way you can do so, return -1. Okay. So mm, so to solve this problem, the key concept here is that you have to somehow convert this problem to from a 2D problem to a 1D problem. Okay. And the way it converts is that, remember, so here, if you guys remember, so here, right, so the based on the we can think of this thing as a like a trailing zero here, right? So basic as for example, this three with a 3 by 3 diagonal 2D grids here, the first row needs two trailing zeros, right? And the second row needs one trailing zero, and the last row needs zero. Basically, this is our target. This is our target, right? And how about our starting point, right? The start is what? Start is, so the first row has zero trailing zeros, and second row has one, right? And third row has zero. Okay. Mm, yeah. Let me see. Sorry, I think here, so the last one should be two. Yeah, the last row has two leading zeros, right? Here. That's our starting point here. Basically, the first row has zero trailing zeros, and the second row has one, the third row has two. So now the problem will be converted to from the starting point to the target point. What's the minimum swap that can be converted from the starting point to the target point? Okay. And the way we're doing it is we're using a greedy idea here. Basically, we always start from the first element, and then we start from the first element, and second, and then third. So why this greedy method work, right? Because every time we're always trying to basically to satisfy the most the rows that needs the most trailing zeros, because we're starting from the first one, and right, and the first row needs the most trailing zeros, and then the second row, and then the third row. Okay, and basically we're starting from this current row here, and we'll be trying to find out what's the earliest row that can satisfy this current trailing zero count. If it is so, we will just do a bubble bubble sort stuff. Basically, we'll move this the first eligible number to the to this position. Okay, and after that, we'll consider we'll consider the second row, and then we keep doing it until we reach the end. Okay, and meanwhile, while we're doing the loop here, if we couldn't find such row, right? If we couldn't find such row that can satisfy our requirements of the trailing zeros, we simply return a minus one. Okay, cool. So with that, let's try to code these things. Basically, we're gonna have answer first 0, right? And then we're gonna have like a n equals to length grade, and then we're gonna have like a trailing zero array here. Okay, and to calculate the trailing zeros, we simply loop through from the last row, from the last column to the first column, right? And we're doing this for each of the row here in grade, right? And then for I in range what n minus one, right, to minus one. Basically loop through from the end to the start, and then okay, if row, if not row, basically if row I equals to 0, right, we do a count. We do an increase count plus 1, else we simply break. Okay, and in the end we just do a trailing 0 dot append count. Okay, so basically that's how we get the trailing zeros for each row. And now all we need to do is we just need to find the target, right? So basically for I and count, right, in enumerate trailing zeros. Okay. Basically what's our target, right? The target of the current count is the target, basically target zeros will be the n minus I minus 1, right? Basically that's gonna be the target of the trailing zeros, we need for this current row here. And we just need to find out if we have such row, right? And also if the current row, if there's a such row that can satisfy this minimum trailing the target. Okay, and then the way we're doing the loop here is we assign it, that's our starting point, basically the k, right? And then we do a while k, that's the sanity check, right? And the trailing zero and k, right? It's smaller than the target. So while this thing is smaller, right, we just do a k plus 1. Okay, we keep looking it until we find one that's satisfy this target, right? And if we couldn't find one, right, so how can we check if we couldn't find one? Basically, if the k equals to n, right, that's how we do a check. If after looping through everything, if the k is still not there, we still couldn't find such thing that's the trailing zero can meet our target, right? And we simply return minus 1. Okay. Else what? Else we find one, right? And if we find one, then we know, okay, so the current k will be our answer. So and then the swaps we will need to do to make this target row to move to the current I position will be what? Will be the I minus k. Uh, sorry, it's going to be k minus I. Sorry, since we're increasing the k here. Okay, k minus 1. Yeah, that's going to be the answer we will be updating. And then we'll need to actually do the swap here, right? While k is greater than I, right? Basically, we swap. We'll move this case element to the current i's position. So we just simply do a z dot k uh, we swap. Okay, k dot k minus I equals to uh, k minus 1 uh, k, right? And then we do a k, we decrease the k by 1, and in the end we simply return the answer. Basically we keep swapping this current k with the previous one, right? And then we keep doing it until we do it like k minus I times to move this current k to the positions it needs to be. Okay, let's try to run it. Yeah, so it passed. Basically, I mean, the real trick for this problem is you have to somehow realize that, okay, to make this to make this a valid binary grid, you have to have list like this are kind of trailing zeros. That's our target trailing zeros. And you have to somehow convert this 2D problem into this 1D problem. Basically, it's like for each of the rows here, that's our target trailing zero counts. And we have to basically process the rows one by one from the top because this is kind of greedy concept here because the top one, the first one is always requiring the most trailing zeros. And once we satisfy that one, and we can keep processing the second most trailing zero rows. And we're doing so by looping through to the remaining rows. Okay, and if there's a such row that can satisfy our target, then we first we update our answers, and then we will basically doing the swap. Yeah. So and yeah, I think for me, the greedy problem sometimes even more difficult than the dynamic programming problem. So I think for the greedy problem, it's for the greedy problem, the most difficult part is how can you prove that, right? I mean, for the greedy problem, you just have to be kind of like having this kind of thinking model, right? I mean, you have to be basically trying to approach to that problem. For this problem, it's just you just have to think of in a way that you have to process the most the rows requires the most trailing zero first, and then because once you finish processing that one, you will not affect. Basically, that's going to be the optimal solution at each step, right? Because when you satisfy the rows requires the most trailing zeros, then you have solved the most of the problems, and then you just keep going until solving all the remaining problems. Hmm. Yeah, I think that's it for this problem. Yeah, I hope you guys like this video, and thank you so much for watching it, and stay tuned. See you guys soon. Bye bye.